Hello everyone and welcome back to another lesson in our trades training video series. I'm Joe Carswell, and in this lesson we're going to cover the tape measure and all of its parts and pieces and methods on how to make it work. So let's get right into it. As usual, we will have a presentation displayed up here from Teach Construction we'll follow along with, and all of my close-ups are going to appear down here. So why is this such an important tool? I would argue this might be one of your most important hand tools. You will use it all day, every day, and your accuracy and the quality of your build is completely dependent upon this tool and your ability to use it. So this tool can make accurate measurements in the field, your built environment. You can evaluate it with this tool. You can take measurements off of plans and apply them there. You can produce accurate layouts, and a layout would be a series of measurements along this tape measure. You can also use a tape measure to check for square or right angles in your built space. Let's go over the parts of the tape measure. First one to talk about is the case. Durable, protective plastic to cover the parts that need protection. That's going to be the internal parts. This is going to hold all of the blade once the blade's retracted. The tape or the blade, this is the part that does a lot of the work. So this is a very thin metal strip that has very sharp edges. That's why we're going to refer to it as a blade. It's got all of your numbers and marks on it, and they're going to go up to the certain distance that the tape measure is built to. A typical length of tape could be 16 feet, 25 feet, 30 feet. A 25 foot is probably your most common and useful on the job site. Keep in mind that the blade or the tape is the part that is the most fragile of this tape measure, and if it is out, it's always in danger of being damaged. Once it is retracted into the case, it's much more protected. The blade lock. This is a feature that I only use every once in a while. It's here to stop the blade out, and it will lock that blade in place so we no longer have to hold it. It's important to mention that the blade is spring-loaded, so it's going to retract into the case whenever it's released. The blade lock on this one slides down and it clamps that blade in place. There are other versions of blade locks. This is a lever lock made by Stanley. This one is always on. So this blade lock is always off until it is slid on. This one is always on until this lever is pressed. Once we press this lever, it's going to release this tape measure, and when we let go of it, it's going to hold that tape in place. So for this tape to be retracted in, we now have to push that lever in. Here is that lever lock, and there's one thing to mention about a lever lock. You will find your own preferences in tools on the job site. A lever lock becomes very comfortable for people over time. I prefer the old-fashioned type of the always off lock button, but a lever lock always has to be pressed in if you want to pull the tape out. If you start to develop a habit of fighting that lever lock and not releasing it, you will burn that lever lock out. It's like a brake on your car, the emergency brake. If you're driving your car and you never release the brake, it won't work anymore. As you can see, this tape measure with the lever lock does not hold anymore. That's a true sign of an abused lever lock tape measure. The hook on the end of the blade is one of the most important parts when it comes to accuracy of a tape measure. It's a bent piece of metal that's riveted on to the blade, and it's going to move slightly. As you can see here, it's going to move back and forth. It moves exactly the thickness of the metal hook, and that's so that whether you're pushing it up against something or you're pulling it, that it is always going to zero out. So some people think that that looseness in the hook means that it's broken. It actually means that it's functioning properly. It's really important that the hook stays true and bent exactly like it is. If it ever gets tweaked or damaged or deformed, it will change all of your accuracy with a tape measure. The belt clip, this is a feature worth mentioning, and the reason that I will mention the belt clip is because I'm always harping on students to keep their tape measure close. There's no excuse for not having this tape measure close. And so now with this belt clip, I can always hook it either on my tool bag, it goes in my tool bag, or on myself very close. It should be very close to your hand, very accessible and very convenient at any moment. This makes you productive. Let's go over some techniques that make these parts work. Extending the blade. I see this issue a lot when training, and the tendency for people when they're taking measurements, say I'm measuring to this point right here. As you see in this photograph here, the tendency is to hold the edge of the case right at your mark, thinking that that helps you to index your dimension or your measurement. The truth is it's hiding or masking these numbers on this tape. It ends up being really confusing. The simple thing to do as a habit when you're taking any measurement is extending that tape measure beyond the edge that you're measuring to. What that will do is reveal those marks on that tape measure to you, and it's very obvious now how to read those marks. Twisting the tape edge flat to a surface. This is a technique that I preach constantly, and think of it like a dustpan. So if you have a dustpan and you want to sweep up a pile of dirt, you want that dustpan to make complete contact with the surface. Think of your blade as a dustpan. It's curved, and we'll talk about why it's curved later, but when you lay this curve on a surface, as in this photograph, a slight twist will put one of the edges flat to that surface. Now you don't have all the shadows and the confusing gaps that will make your dimensions inaccurate. So that slight twist, and I even do a little more mystery solved here. I even use my pinky to hold it down right where I'm going to make my mark. So the flatter that edge is to the surface, the better the measurement, the more accurate you can transfer that mark of the tape to the material that you're measuring. Sighting the tape. This is another trick that can cause inaccuracies or accuracies depending on how you do it. Think of your eye needs to be directly over the mark that you are getting ready to read. So your body position, your stance, your eye needs to be positioned directly in front of it. If you read from one side, this would be if you read from the right side in this measurement, the measurement will read short, especially if there's any radius on that edge. If you read from the left, then the measurement will tend to look longer. So you need to be directly in front of it, sight it right here, and you will get the most accurate measurement you can get. Bam. Understanding parallel is really important when you're measuring. We need to be able to see by eye when our tape measure is in line with our material. As you can see here from this photograph, if you are out of parallel with what you're trying to measure, you can make that dimension grow, in this case up to 1/4 of an inch. Perpendicular works the same way. I'm going to demonstrate those here in a second. But if you parallel and perpendicular are related to each other. So if you can find or identify an edge and make the tape measure 90 degrees to that edge, you can also achieve that most accurate measurement. So if I'm here with this tape measure, and I'm going to tilt this towards you, and I am going to move it back and forth, that measurement is going to grow to each one of these edges. If I place it parallel, then that is going to be my shortest and most accurate measurement. So this measurement, ideally, if we read it accurately, is 29 1/16. If I swing it out of parallel, I'm going to grow by 1/8 of an inch. Now I'm 29 3/16, and that's the same here too. So as you can see, accuracy is very important when we're talking about parallel. So now that I've moved everything out of the way, perpendicular comes into play when you do not have a parallel line to reference. As in this table, I don't have one close enough that my eye can make sense of it. But now we can use perpendicular. So we're going to use this front edge of the table. We're going to measure from that edge to the back edge. and I'm going to hook this tape on here. The depth of this table is 24 inches, and if I swing this tape out of perpendicular, that measurement can grow at this point up to 25 inches and up to 25 inches here. So we can swing, if you're confused about this, you can't quite figure it out, then you can swing it back and forth. Once you get to the shortest measurement possible, you have found the perpendicular line, which is going to be your most accurate measurement. Now we have two different types of measurements to talk about. These are your basic techniques for measuring, and this will carry you through a lot of this tape measure use. First one we're going to talk about is a push measurement. And a push measurement is very simple. We talked about the hook and how it moves. We're going to push this tape, push this hook into an edge, just like that. We're adding pressure. The curve of the blade is going to keep that blade stiff, and it's going to allow us to keep a straight blade. We've got parallel. We're pushing the hook up into this corner. The hook is moved out of the way. It's zeroed out. Now we can read the edge wherever we need to. So let's look a little closer at a push measurement, real world, see how that works. Here we have the tape. It's being pushed into this corner. The next thing you're going to do is to pull out enough tape to go beyond that edge that we're talking about. We don't want the case in the way of the edge that we're trying to sight. You're going to keep pressure on the hook. We want our sight line directly over the mark. And now we're going to twist that tape flat and sight and read these marks. That is a typical push measurement in the field. The second one to talk about is a pull measurement method. So this is where we're going to take the hook of the tape. We're going to hook it on a hard edge. We're going to add tension to the blade. We're going to pull it parallel, and we are going to twist this tape measure flat so we can read this edge. Let's watch that here. Here it is hooked on the hard edge. We're going to pull it out, and remember, you want to go beyond your mark or your intended mark to keep the case out of the way so you can sight that mark. We're going to twist that tape flat, and you're going to twist it towards you. Now we have a flat connection between the blade edge and where we need to mark. We're going to find the mark, and we're going to mark it. A push and a bend is sort of a combination. It's a little more complicated. Every once in a while, you have an interior space that you need to measure, and you do not have a way to do an exact push or an exact pull. So you're going to call it a push and a bend. So you've got two inside corners. We're going to push that tape into that corner like a push measurement. We're adding tension to the blade, and now we are going to bend that blade into the other inside corner. By extending this blade and bending it, this is not the most accurate way to measure, but the better you get at it, the more accurate you can be. So the trick of this is, we talked about parallel. As you can see, that comes into play, and also sighting the marks are going to be very important too. And we're going to show that a little closer here. Here is the bend and sighting the bend. As you can see, the tape is curved. Let me demonstrate that here. And this should show up a little better for the camera. So we've got this here, and we're going to bend it in here. As you can see, if you bend that tape too hard, it's going to crease, and then the tape's no good. So what we're doing is we're bending it in, and we're giving it a guess. And the more you use a tape measure and practice this cut, fit, you will get better at this. I would call this measurement on the presentation, I'd call it out at about 42 3/16. The thing is, you're going to want to guess a little heavy or a little long, because if you cut something to that length, you don't want it to be short. You can always cut it a little shorter. I would guess at that bend about 42 3/16. One other method that is a precision method of doing this interior corner to corner is going to be a double measure. And doing the push and bend is going to get you close. The double measure is much more precise, and I'll show you why. So we're going to do a typical push measurement into this inside corner, and then we're going to make a mark at a number we can remember. This requires a little math, but not crazy math. So at this point, as you can see, I'm going to choose 20 inches. I feel like I can add 20 inches to anything. I pick my numbers in tens. Some people like feet. It just depends on how your mind works and what's easiest for you. So the second thing, you're going to flip the tape measure around and do another push measurement into the other corner. Of course, you're reading the tape upside down at this point, but you're going to take those two measurements and add them together. So this measurement is 11 3/4 to that first mark that we made. So now we take the math, we add them together. I started with 20 inches. My second measurement was 11 3/4. So my total distance between corner to corner exactly using this method is going to be 31 3/4. So let's try this double measure method here. I've got an inside corner to corner here, and we can create an exact measurement for this using the double measure. I'm going to pull my first measurement from this corner over. That's going to be a push measurement into there. I'm going to twist my tape in here. I'm going to make a mark at, say, 36 inches. I feel like that's going to land on this stud, and I can remember that measurement. So I'm going to start with 36. Now I'm going to get another push measurement over to this mark. And it looks like I'm at 16 1/8. So we're going to add 36 to 16 1/8. That's going to give me 52 1/8 inches. There are some even more complicated methods of using a tape measure. Sometimes you need to make vertical measurements, and you can do these without needing a ladder, and you can do them solo. So let's go over a couple methods to measure vertically. From the bottom up, let's start with this one. There's two, we're going to call one bottom up and one top down. So from the bottom up is just like it sounds. The tape measure is going to get pushed into the floor, and you're going to extend that tape measure up to the ceiling where the ceiling would meet the walls. And this is just a version of a push and a bend that we're doing vertically. First step is going to be pushing the hook to the floor, and we have to extend out enough tape to reach the floor. The next is going to be shuffling or extending out more tape. We now need to reach the ceiling with this tape measure. So holding that tape to the floor, we're going to extend more tape out. As the tape gets extended, we're also holding it to the floor. We're getting closer to the ceiling. At this point, we have enough tape out that we're way beyond where we need to be with the ceiling. We can now, with tension, we can bend that tape into that ceiling corner. So consider your floor is one inside corner and your ceiling is the other inside corner. Finally, we're going to push or bend that tape into that corner, and we have to sight it from where we are at the floor. I talked about our sight lines, and this is not a very good sight line to measure from. I would not consider this the most accurate way to do this vertical measurement. Another way to do it that tends to be more accurate is going to be from the top down. The trick is you have to hold the tape at the top and now push the bend into the floor. To start with, we're going to hold that tape up. We're going to extend it to the ceiling, push the hook into that corner, and now we need to hold it in place there. As we're holding it in place, we need to extend more tape out. And this is a harder method, but it's more accurate. As we're extending it out, I'm now wrapping this tape, believe it or not, around my knee, and we're going to extend more out. As you can see here, this is my Karate Kid move, and we've got more tape than we need. Now we can push that bend into the floor. The reason I believe this is a more accurate method to measure vertically solo is because now I can kneel down and I can get a much better sight line on the floor right where that tape meets it. There are some special considerations to think about when using a tape measure. The standout, and the standout is related to, number one, the width of the blade and also the curve of the blade. We talked about the curve and how we have to sight it and how we have to twist it. The reason that curve needs to be there, it would be great if it wasn't there, we could read the tape a lot easier, but the curve is what allows us to use this tool solo. So I can hold this tape measure out and it will keep extending out further and further and further, and at some point, I'm going to go past the camera, we'll see how far it will extend out. So I am at 6 feet, I'm at 82 inches, and that tape measure is still holding. I'm going to get a little further and it's going to break. That tape measure broke at about 87 inches. So this tape measure has a standout of around 85 inches. The standout is what's going to make this a one-person solo tool, and you don't need to babysit the hook. You can reach over to things using the standout, grab an edge, and it puts your sight line right at the numbers that you need to read. Burning an inch is another technique that is used sometimes when you're going for accuracy. We always like to hook and make it quick and keep rolling, but sometimes it is more accurate to hold the tape measure on a specific number, and then you're reading from one mark to another mark. And this tends to be confusing at first if you're just learning the tape measure, but sometimes your hook is not as accurate as you want it to be, or the edge that you're trying to read from or to is not as accurate. So sometimes burning an inch makes a lot of sense. The way you burn an inch is to shift the tape measure over. So as you can see here, we're using the hook on this edge. If I was to slide that tape measure over 1 inch, I can use the 1 inch mark to measure over. And I know that from 1 inch mark to the 7 inch mark is exactly 6 inches space in between. The problem is that you have to remember to subtract whatever inch that you burned. I like to say burn 10 inches because you're never going to make the mistake of the 10 inch like you would forgetting the 1 inch. So let's see what burning 10 inches looks like. First, I'm going to just do a simple pull measurement. Hook it on this edge with tension. I'm going to tilt the blade, and the edge, it's reading 15 and 11/16. So if I burn an inch, 10 inches, I'm going to pull out here, place my 10-inch mark on that edge as close as I can get it, and I'm going to read the mark. It says 25 and 11/16. Remember, we added 10 inches, so now we're going to remove the 10, and we're left with 15 and 11/16. My two measurements were exactly the same. What this tells me, this is a very easy way to verify that your hook is working properly. There are some other challenges when we're talking about tape measures that are not completely obvious, and that is if you're a right-handed person, you're always marking with your right hand. This means that our tape measure has to be in our left hand and we're operating it with our left hand. The other thing that comes around when you're using this tape measure with your left hand is that the numbers you'll have to read upside down. This has always been amazing to me. I don't know why they make them this way. They make them for left-handed people. So you're welcome, left-handed people, you have a tape measure that works for you. For right-handed people, we now have to look at certain numbers like 6s and 9s and make sure that we don't get them confused because we're reading them upside down. Certain numbers like 8s don't matter. And even when we get up into the hundreds, say you're at 112 or some number where there's 3 numbers, we also have to flip those over in our mind and make sure we make an accurate reading. So from my perspective, if I hook this tape measure here, I'm looking at these numbers upside down. Now, if I'm doing them from the camera angle as you're seeing them, that would look like this. So as you can see here, my 6 looks like a 9, and my 9 looks like a 6. Okay, so we have to flip that over in our head. It's a constant process we have to do. We have to double check ourselves, and your accuracy is dependent on you being able to interpret this tape measure either left-handed or right-handed. Hook traps. This is a sort of a care of the tape measure situation, and a hook trap happens because the hook is thin and it's going to reach over. You're using your standout, you're extending it to a distant place, and often that tape measure can get hooked in a gap. So the worst thing for you to do would be to yank or pull on that tape measure. The best thing to do is going to be to go to the hook and then remove it by hand. It's a very careful process. I'll tell you that this tape measure, this first foot of this tape measure takes the most beating. That is the most abuse and use. And most tape measures will fail within this length of it. And it's because of these issues with tape, with hook traps, and the tape gets used a lot in this particular area. You may have a situation like this. So here this hook has grabbed in between these two pieces of lumber. As you can see, it's going to do nothing but damage to this tape measure if I try to force it out. The easiest thing to do will be to just pry it out by hand. This is what it looks like when you don't take care of your tape measure. All of these creases and bends are going to reduce the accuracy of this tape. The two tapes you see here are no good anymore, and water, dirt, debris, the marks get worn off from this kind of abuse and lack of care. When you extend it out for a long distance and it gets stepped on, that's also going to be the kind of abuse that's going to ruin the tape measure. I don't know if you can see on this tape, but this one, I'll try to get it, the light on it. This one's starting a crease right here. And a lot of this abuse is going to happen in this first foot of this tape measure. Some other tape measure hazards: in extreme cases, there's going to be a nick in the blade, and the blade is sharp as it is, so keep in mind when you're retracting it, do it under control. All of this tape measure use is completely under control, but a bend or a crease tends to turn into a break, and a break tends to turn into a nick. And this kind of a nick can be literally a razor blade. So you can imagine as you're retracting the tape in, if your hand is near the blade, this could be a nasty cut. So at the point that your tape measure is in this condition, you can consider it no good and needs to be replaced. So this is a list of terms used when we're talking about measuring and tape measures. And as always, I like to stress this idea of learning these terms and using them on the job site. Knowledge is power, especially when we're building. So I hope you've learned something about tape measures, their parts, and how to use them, and how to make them more accurate. This is a key skill that we all need to master. So that's a wrap. Let's get back to work. This video is a production of Trade Skills U, all rights reserved. If you provide instruction in the construction trades and have a need for videos like these, please contact us at tradeskillsu.com. The presentation and the images used in this lesson video were provided by the Teach Construction Initiative. If you're a teacher or instructor and would like access to these and similar resources, please visit us at teachconstruction.org for more information.